reminder, your category is Problems in Bioprocess Engineering.
Is it an ethanol extracting process?
That's correct.
Here with the bioprocess engineers, we not only want to educate you on a problem in bioprocess engineering, we want to prepare you for real-world situations where you can use this information to benefit you. And what's more real-world than game shows? In the rest of our video, we will be introducing you to a problem in bioprocess engineering and showing you situations where this information might be useful.
Sadly, neither of the two families could identify any part of the ethanol extracting process and instead resorted to petty bickering. What the answers are, survey says, dry grind, wet milling, and lignocellulosic process.
Wet milling and dry grind are the two current processes for extracting ethanol. The next two graphs will represent these processes in different ways and each step by step.
I'll take ethanol production for 100.
Other products of the process that can also be sold.
What are co-products?
Correct.
I'll take ethanol production for 200.
Another co-product that is of a desirable composition is not widely used and is only 1/3 of the total process.
What is distilled dried grains oil soluble?
Correct.
This co-product is called Distillers Dried Grains and Solubles, or DDGS, and it can be used as livestock feed. If the process of extracting ethanol were to be changed, more fiber could be removed from the DDGS, and the DDGS could be more widely used. Overall, the problem with the ethanol extracting process is that it needs to create better co-products.
So for this next game, all you need to do is take these three methods of ethanol extraction and put them in the correct order of price.
Alright, I'm gonna do this. I'm gonna win that solid gold toilet seat. Alright. Okay, I think I got this. I'm feeling myself. Is this right?
I'm sorry, that's not correct. While all of the processes create the same ethanol, not all processes of extracting ethanol are the same price. They also all end up with different co-products. The dry grind process is the cheapest, but its co-products are worth the same as the corn going into the process. This leaves no profit for 1/3 of the total outputs. In wet milling, the co-products are worth more, but the process is 3 times the price. Even more expensive than the other two processes is the lignocellulosic process. Its co-products are worth more than the co-products of the other processes, but the expensive processing offsets that worth. Process research can improve co-product value. An enzymatic dry grind process can improve the co-product value by creating a high-valued germ and a more widely usable DDGS with less fiber so that more livestock can feed on it. If the lignocellulosic process was changed so that less pretreatment was needed, the enzyme manufacturing costs would decrease, giving a higher performance in the process and making the process more economical with workable co-products.
To improve production of the co-product corn oil, the new enzyme Alexa facilitates the separation of the oil from the corn germ. As for the actual process, new enzymes Avantec and Spirizyme Achieve lead to an ethanol production increase of 5%. They turn starch to glucose more efficiently than any other enzymes currently available. Many researchers are working to decrease the time production takes. A promising choice is the enzyme GSH, which has characteristics of both alpha amylase and glucoamylase. This turns the 2-step process of converting starch to glucose into a 1-step process. To improve this process's speed and ethanol yield, researchers have worked with pretreatment processes such as an ammonia fiber explosion treatment. The biggest problem, however, is logistics. Corn stover is bulky but not dense, very hard to transport. Once someone figures an economically sound way to get it from the field to the plant, improvements will follow.